So now that I've given you an overview of the structure and functionality of the server components in the PrimeCheckApp case study, let's actually take a look at the implementation of those server components. And so what we're going to do here is I'm going to walk through the implementation of the PrimeCheckController and the PrimeCheck Service classes that run in the context of the PrimeCheckApp server or the PrimeCheck application, as we'll see here in just a moment. And of course, you can get all of this code here at the link at the bottom of the slide and follow along. You can see here I'm in the server folder in the IntelliJ project for this particular example. And there are three files. There's PrimeCheck application, PrimeCheck controller, and PrimeCheck service. And this is very common when developing servers with Spring. You'll see later when we talk about microservice-based approaches that typically each microservice is also split up into those three pieces: the application, the controller, and the service. So let's start first by taking a look at the PrimeCheck application. This class provides the entry point into the Spring Web MVC-based version of the PrimeCheck app server. And as you can see, it's got some annotations here. It's got this annotation that says Spring Boot Application, and that basically tells Spring to enable the use of auto configuration and auto wiring, component scanning, and then also defining extra configurations on the entry point application class. And you'll see that the property source annotation indicates where to find the properties file that's used for this particular application. So this is a way of being able to declaratively configure your application without having to write extra code. You can make changes to this file without having to recompile the code. And you can see here that that file is located here in the resources portion of the application. And here's what this particular properties file looks like. It says the name of this application is PrimeCheck Server, and the port number it listens on is 8081. So again, we could change that without having to change the code. Here's the main entry point into this server. As you can see, it parses the command line arguments and basically initializes the options singleton, which we use for various debugging purposes primarily. And then it goes ahead and calls Spring application run, passing in the class file for the PrimeCheck application. And that will set all the wheels in motion where the various scanning and auto wiring and other initialization procedures are done in order to bring up the application when it starts to run. And keep in mind, this is the server application. So let's turn our attention next to the PrimeCheck controller. So this is a Spring controller that demonstrates how WebMVC can be used to handle HTTP GET requests using this Java Streams framework. And the requests, as we'll see, that come in are mapped by the Spring WebMVC infrastructure to these endpoint handler methods. And they are going to determine whether large random numbers are prime or not. And there's a bunch of other things we'll talk about in a moment that are important. This is a very common approach. This can be used for all kinds of different mappings. It can be used for GET requests, POST requests, PUT requests, delete requests, and so on. And that's all managed automatically in Spring by using something called the REST controller annotation. And the REST controller application also tells the controller that the object returned by the various endpoint handler methods we're about to look at should automatically be serialized into JSON and passed back to the client within the body of an HTTP response object. So you don't have to write all that code yourself. It's done for you automatically. We'll also see some use of GET mapping here that I mentioned earlier. So here's the PrimeCheck controller. As you can see, it's auto-wired. So it auto-wires the service. We'll take a look at the PrimeCheck service in a minute. And that is what is at the heart of dependency injection. So that's how it gets connected up. And then down here, you can see the first method, which is called checkIfPrime. That's the name that we give it. We don't have to call it that. I called it that because it's intuitive. What's most important here is that we have a string, which in this case is the /checkIfPrime string. And that's what is used by the underlying WebMVC framework and the controller logic in order to direct incoming requests with this particular URI to this particular method in this particular object. And so that's what GET mapping is doing here. And you can read a bit more about GET mapping up here. So it basically maps the requests. What happens when a request gets mapped is that the underlying Spring WebMVC infrastructure will convert the incoming request, which is in string form, into an integer, and then that integer will just be forwarded to the checkIfPrime method on the PrimeCheck service. And we'll look at that in just a moment. Taking a look down here at another method, this is called checkIfPrimeList. The main difference is it takes a list as opposed to a single integer. And you can see again, we have the get mapping with the checkIfListPrime string, which is a constant, but it evolves or devolves into a string. And then down here, you can also see that we have the request param annotation, which indicates to Spring that this request that comes in as a string of comma-separated strings that represent string versions of numbers should be converted into a list of integers automatically by the demarshalling process that the Spring controller does on your behalf. And you can see again, all we do here is we take the prime candidates list and the Boolean flag that indicates whether we're running in parallel or not, and we go ahead and forward that to the checkIfPrimeList method on the service. So having said all that, let's now go take a look at the service. And this is where the actual work gets done. These are the implementation methods that implement the business logic. And as you'll see, sequential or parallel streams are used based on parameters that the clients pass in. So here's the PrimeCheck service. You can see it's annotated to be a service. And by doing that, that indicates that the class implements business logic and also tells Spring to do auto detection and wiring of the dependent implementation classes using so-called class path scanning, which just looks in the folders and finds the implementations that need to be wired together. So here's the checkIfPrime implementation. You can see at this point, we're really no longer dealing at all with HTTP kinds of things like get requests or put requests or post requests or request param annotations. Now we're just in good old Java land with native Java types like integer. And down here we have list of integer. And you can see what happens here is that checkIfPrime, when called, calls the isPrime helper method. IsPrime is what actually determines if a number is prime or not. And you can see the first thing it does is it gets rid of things that are even multiples of 2, just no sense even trying to check to see if they're prime because we know they're not prime. And then it starts at 3 and goes up, skipping over the even numbers. So it'll go 3, 5, 7, 9, 11, and so on. And what it's doing here is it's checking to see if the factor, which starts at 3, when used to mod the number, the prime candidate n, if that returns 0, that means that it's not a prime. It's a number that's got a divisor, a factor. So we return the smallest factor in that case because we start at 3 and go up. And likewise, if we get all the way through that loop and there was no common factor, then we know the number's prime, so we return a 0 to indicate that. And you'll also notice that about every 1,000 iterations, we check to see whether or not we've been interrupted. And that's a way that we don't just keep running blindly doing a large prime factorization when the client has told us to go away or someone's clicked a GUI to tell us to go away. We don't really do a lot with that at this point. So let's go ahead and go back to the calling portion. So you can see we find out what the results are, and then we return the result. So checkIfPrime is very simple. More interesting, however, is checkIfPrimeList. And what this does, as we had kind of talked about earlier, this takes the list of prime candidates, converts it into a stream, and then conditionally converts it from a sequential stream to a parallel stream if that's what the client requested by passing in the true for the parallel Boolean. And then irrespective of whether we've got a parallel or a sequential stream, we then take each element in the stream and map it to the isPrime method using a method reference here. And then we end up taking the results of that and we collect that into a list. And then we go ahead and conditionally display the results if we have debugging enabled. And when we're all done, we go ahead and return that list of results. So that's essentially what's going on with the implementation of the PrimeCheckApp server. So the PrimeCheckController, the PrimeCheck Service, and also, of course, the PrimeCheck application itself, which is how we get into this server side from the client in the first place.